in what ways are crows demonstrating certain types of intelligence that differs from ravens? Like where are those differentiation points?
Let's take one step back and just talk about kind of how we understand this in animals. So when we're asking questions of intelligence, because it is kind of hard for folks to be like, how can you measure that as a person, right? Like, how is that not just completely clouded by your own hubris?
That's how I always think.
Yeah, to some extent, of course it is. The sort of strategy we've taken is trying to identify features that we've demonstrated imply a level of executive function and cognition that separates it out from instinctive trial and error or other forms of behavior that require a very simplistic mechanism. So the best way I can describe this, when you think about ants, think about the incredible things an ant colony can achieve. Right. Building bridges, building barges, like all of these things. It's not, and I think we can all agree, like ants don't have little degrees in physics and they're not building bridges because they we understand more about the world than an ant does.
Certainly. Yeah.
And so that's a good example of how really simplistic mechanisms can build to a really sophisticated outcome.
The way I've thought about ants, is like basically that's like an emergent behavior of a colony type of species, right? Where it's like I almost think of ants like, and look, I'm certainly you're more experienced in this world than I am, but I have my weird ways of thinking about things. I go, ants feel like almost like the cells of an organ, which has greater function. The cells do not understand what they're actually doing. But nevertheless, the heart pumps, right?
Exactly. Exactly. And so our goal when we ask questions about like, how smart is a crow, is trying to tease out, like, is this a sophisticated outcome that's guided by a really simplistic mechanism? Or is this sophisticated, complex thinking that's producing a complex outcome?
Okay.
And so we have what we call our sort of cognitive toolkit that guides us in understanding that. So that's whether or not these animals can demonstrate things like causal reasoning. So do they actually understand the relationship between what they do and the outcome that it produces? Or do they just go through the motions because evolution has taught them that it's really helpful to do that? Right. So that's one. Flexibility is another. So can they sort of change course with new information or in a new context, right? We do that all the time. And anyone who's raised children has watched that skill develop, where suddenly they're like, oh, I learned this thing in this context, but I'm going to reapply it.
Translation, yeah.
So causal reasoning, cognition, flexibility, imagination is another really important one. That's something we take for granted because it's such an essential, part of the human experience. But it's actually incredibly difficult for your brain to imagine things that aren't happening. It's very hard. Yeah. So demonstrating that, prospection, which is mental time travel. So those are kind of the main features that we look for.
Interesting.
And we've seen bits and pieces of all of those things across the variety of corvids. So scrub jays, for example, really good at that prospection, that mental time travel. And we've been able to demonstrate that through a variety of experiments, looking at how they hide food for later and their understanding of where to put food based on new information that they get or how quickly to recover food.
Right.
Ravens are really good at imagination, so they can imagine competitors that they can't actually see. That probably has a lot to do with these really complex social lives that they lead and these very sort of political dynamics that they have. New Caledonian crows, which is a species that lives on New Caledonia, are one of the only tool-producing animals in the world. There's less than a handful of animals, including ourselves, that manufacture tools rather than use tools. Tool use is about 1% of all organisms, but tool manufacturing is like, 4 or 5.
Species total.
Species total.
Us. Yeah. Let me see if I can guess. Us, the New Caledonian crow, and then like 3 primates.
So there's a cockatoo. That's one of them. Yeah, and then a couple of primates. And primates are a little tricky because there are more primates that do it in like captive zoo settings. That's also true with crows. The now extinct in the wild alala, which is the Hawaiian crow, produces tools in captivity because that's the only remaining population of these birds, but they probably did it in the wild too.
Okay.
So that's why that number is a little wishy-washy, but it's very small relative to the number of organisms. That's the main thing, very small. And so, put together, this family demonstrates all of the features that we've identified are sort of the most difficult things for a brain as we understand it to do.
I'd love to dive in a bit deeper, maybe just starting with crows themselves.
When we say crows, we're describing a bunch of different birds.
Yeah.
So we could be talking about American crows, fish crows, New Caledonian crows, hooded crows, carrion crows. And so our understanding of their intelligence comes from, human observations of these birds, right, that span across the globe and across time. I think certain communities of people have appreciated how intelligent these animals are for a very long time. And then in complement and kind of alongside to that traditional knowledge is then the Western scientific work that has come to sort of in that scientific method approach, attempted to then tease that out in that specific way. Mm-hmm. And so through that effort, we have been able to figure out that these birds are incredibly intelligent. And that was a big surprise I think, we're all familiar with that term bird brain, right? For a really long time, we in the Western science community didn't really appreciate that birds could be smart. And a big reason for that is that the brains of birds are very different from the mammalian brain. And of course, science is always going to be, clouded by the sort of our hubris and the whatever cultural norms are, in that moment. And so for a long time, we thought of intelligence on this linear scale, all leading up, so the brain is when we thought about it as across animals, right? We have all of these different versions of the brain that then lead in the culmination of the human brain. And so if it doesn't look like that, it's much less sophisticated. A big difference between the avian brain and the mammalian brain is that bird brains are smooth. They don't have the many folds that our brains do. And the reason our brains have those folds is to provide more surface area, more neuronal density, et cetera, et cetera. So we were like, bird brains, they're smooth. They look more like reptilian brains. Done. They're probably very simplistic, right? Primitive.
Yeah.
And we were wrong. We were just wrong. So we appreciate it more like a Mac and a PC. They are two different things, but they execute a lot of the same kinds of tasks, as it turns out. And in fact, birds like crows and ravens and some parrots have a much higher neuronal density than any of the primates.
Wow.
So they're doing a lot in a very small space because their brains are about the size of a walnut. And that was the other mistake we made, that we thought it was, size mattered.
Size mattered. Yeah. Mm-hmm.
And it does, but only in a relative sense.
Watch the full episode right here and subscribe for more new episodes every single week.